Okay, so if we set up our sine ratio of angle A, the sine of A is equal to the opposite over the hypotenuse. So the sine of A is equal to H over B. If we do the same thing for the other triangle for angle B, we get H over A. And if we solve those ratios for the variable H, then in this case we multiply both sides by B, so we get B times the sine of A is equal to H. And over here we get A times the sine of B is equal to H. Now, what I'm doing here is I am building the law of sines. And I'll explain what it is here in a minute. But it's not coincidental that these two triangles that I've drawn have the same height. Okay, that is done on purpose. So if we have two equations that are equal to the same variable, both of these are equal to H, so essentially they're equal to the same number. So using the transitive property, if they're equal to the same number, then they must be equal to each other. We can set B sine of A equal to A sine of B. Since they're both equal to H, then they must be equal to each other. So if I take these two triangles and squish them together, since they have the same height, I can put the two triangles together and create a big triangle here, which is not a right triangle. I know that you see a right angle right here, but technically that right angle is not one of the angles of the big triangle. That's just the perpendicular segment there to measure the height of the triangle. This is not a right triangle. This is why we need the law of sines. The law of sines exists for cases where we don't have a right triangle, but we need to solve for missing sides or missing angles. We cannot apply right triangle trig. You can't use opposite, hypotenuse, and adjacent when you don't have an opposite, hypotenuse, and adjacent because there's not a right angle in the problem. So if you get one of those yellow sheets there, it's got our notes on it, you will see the same, essentially the same triangle as this. And we are going to set up what the actual law of sines says. Since we just had that expression, B sine of A is equal to A sine of B. Okay, B sine of A is equal to A sine of B. If we get the same letters on the same side, so we want angle A and side A on the same side, we would divide both sides of this equation by A. And to do the same thing for B, we would divide both sides of the equation by B. So what we end up with is the sine of angle A over side A is equal to the sine of angle B over side B. Now, we're not purposefully leaving angle C and side C out. We could come up with the same ratio by orienting our triangles a little bit differently, but it works out the exact same way. So this is also equal to the sine of angle C over side C. Now, we don't actually have equations that have two equal signs in them, okay? What this does is you pick out which two you need based on the information that you're given. Okay, you pick out which two you need based on the information that you're given. You'll see here when we actually do an example. So this can be used to find side and angle measures if we are given any two angles and any side, or two side lengths and an angle outside of them. Also, let's just talk about a little bit of convention. You should be used to this, but angles, we use capital letters for angles, and we use lowercase letters for sides. And notice in the picture that side A is across from angle A, side B is across from angle B, and side C is across from angle C. So that you do need to keep that convention when you apply this to these problems. Okay, so let's actually use this. The directions say find each missing measure, round all answers to the nearest tenth. So when we look there at example number 1, if we just label this the way that the picture is labeled, that 52 degrees is technically angle A, the 34 degrees would be angle B, so the X is side A, the 10 is side B. Now, do you have to go through and label them with A, B's, and C's every time? No. I'm just doing it because it's convenient in this case since it looks just like the example or just like the figure in our definition there. So we've got angle A, angle B, and side B. So we're going to use sine of A over A is equal to sine of B over B. So sine of 52 degrees over the leg that's opposite of that, so that is the X, is equal to the sine of 34 degrees over the leg that's the opposite of that, which is 10. Bless you. Now, when we have a fraction equal to a fraction, bless you, what do we do to solve that? Fraction equal to a fraction. Ratio equal to a ratio. It's always y'all's favorite answer except when it's actually the answer. Cross multiply. Cross multiply. When you have a fraction equal to a fraction, you cross multiply. So 10 sine of 52 degrees is equal to X sine of 34 degrees. We're wanting to solve for X, so then we turn around and divide by the sine of 34 degrees. The signs do not cancel. You still have to put that into your calculator. You want to make sure we've been dealing with radian mode a lot with our equations and whatnot, but what are our angles in here? They're in degrees, so you got to change that to degree mode. Check that first, because a lot of people are in a big habit of resetting the calculator. Every time you reset the calculator, it puts it back in radian mode. So I would highly suggest you try and break that habit if you haven't already, okay? So 10 sine of 52, you gotta make sure you close your parentheses before you divide by the sine of 34. And they say to round to the nearest tenth, so that would give us 14.1. X is equal to, well, we'll say approximately. That's technically, it's not. We had round, so technically that's an approximation. Okay, all right, number 2. This one's oriented a little different. It doesn't matter, okay? You really don't have to label it A, B, and C. Really, you can just jump into the law of sines. So the first angle that I see is the 119 degrees. We put that over the side that is opposite of the 119 degrees. That side is labeled X. The side of the other angle, 21 degrees, the side opposite of that one is 7. Kind of a skinny triangle. It can be a little hard to see that sometimes, but I think the arrows help if you struggle with that. Okay, cross multiply. If you can do this in fewer steps, that is fine. I am just working it all out for the benefit of those that like to see it. So then we turn around and divide by the sine of 21. Now, I will say this, if you're doing this on a quiz and you don't get the absolute right answer, but you didn't write down any steps, it's going to be really hard for me to give you partial credit. So if you like to skip steps, that's fine, but just make sure that you are doing it correctly. So we get 17.1 for that one. Okay, I'm going to skip 3 and 4.